Hello, today I want to talk about my result about optimum ratio between two bases in BB84 protocol with second order analysis. This is the problem, the following problem basis selection in QKD. In usual BB84 protocol, we need to choose bit basis and page basis with equal probability. In this case, only 50% of transmission have agreed basis between the Alice and both sides. If they choose one base with 100%, they cannot estimate the error rate of the channel. We need to address the trade-off between the precision of the estimation and the loss of the disagreed basis in this situation. So firstly, briefly, I explain the relation between the trace norm distance and privacy application. The trace norm between trace norm distance to be bounded is that between the true state rho E and ideal state rho ideal. So we need to evaluate this trace norm, but this trace norm can be bounded by this quantity. So this PPH is the phase error probability after privacy application. So indeed, in the QKD system, if we make privacy application, this is essentially equivalent to the partial error correction on phase basis. So after that kind of partial error correction, we have a very small error probability, phase error probability. So if we have this small value, so we have a good security evaluation. So this is a known result, my previous result. This is evaluation of the Eves-Roberts information. In that situation, L is the number of used estimation and phase error, and N bar is the number of lengths of bit with Alice basis and both basis. So here, this epsilon is the phase error ratio of the final key, and P2 and P1 is the error rate of the transmitted channels. So we have this second order analysis. This is first order rate, but in the second order rate, there is this is Gaussian inverse distribution function of the Gaussian distribution. So here is the epsilon is phase error probability, and this is the second order rate. So then we have this root. So if we apply this result to the containing the that ratio of basis, we have this result. This is our new result. So firstly, we consider that the ratio of the choice of basis. So Alice and Bob choose bit and phase basis with this ratio, 1 minus R0 and R0. And also Alice and Bob choose check basis in the base bit basis and phase basis with this ratio, R1 and R2. And in that case, we have this key generation length. So this is the first order rate, and this is second order rate in this way. So this we have a and this is yes, this is second order rate, constant rate. So in this situation, we need to optimize these parameters R0 and R1 and R2. So after we make optimization, we have this result. So this is R0 optimal choice, this one. So this very subtle quantities we need to consider inverse 4 over 1. And R1 is 0 and R2 should be 1. And epsilon is the rate of final key. So in that situation, we have this asymptotic formula in this way. So why we have this order? Because in this case we have R0. R0 is here and this is here. So due to this R0, we have some small loss. So that small loss is somehow has the order n over n power 4 over 3, and also here is this one, but here is R0 square, and there is n. So due to that effect, we have this ratio. So in this sense, we have this rate. So then we have this one. This is our result. So in this situation, our second order is relatively large because this one is not so negligible in comparison with this linear order. So in this situation, we make this numerical calculation. So in that numerical plot, we have this plot. So this line is straight line is the optimal rate, asymptotic rate. But we have this second order correction. After we make the second order correction, we have these curves. So these curves depend on the value of epsilon in this way. And if n is very large, log n close to 10, so in that case, we don't need to care about the second order correction. But in this range, we need to be careful about the second order correction. This is our result. Thank you very much.